Thank you, everybody. When I reread what I proposed the title should be, I was like, okay, so this is almost a novel. So we could also just call it Why Pods Are Not Virtual Machines. My name is Sofus Albertsen. I'm a former assistant professor doing a lot with learning. Now I'm a DevOps consultant, and I'm obsessed with learning. So everything I do is around knowledge sharing, learning, giving back, and receiving, right? So in this talk, I want to touch upon our history around our learning platform, the revisions we've gone through and why we are constantly changing, the struggles we've had with going Kubernetes for everything, and the learnings, right? Eficode, who I work for, has been doing training for more than 10 years, right? So forget about Docker, forget about Kubernetes and all of that. Back in the day, the hotshot was Jenkins, and over there, Git Crash Course. This is from the Wayback Machine. That's not our website anymore, right? But we have done this for a long time, and we're still doing it, right? So every time we are out doing any of these kind of trainings, we want to make sure that we have a nice experience for the people who are going to receive this learning, right? So how do we normally do this? We do it on a class basis. So we have some students or some people who want to receive learning, and then we have somebody just like me who, for example, is saying Kubernetes is awesome, because it is. And then we have some slides and conveying some knowledge, and hopefully some ideas stick, and then you can go and actually apply this in your real life. But if it was only slides and me talking, then it would be 7.5 hours of very dull time, and nothing would really stick, right? So the only way that we really receive learning is trying things out yourself, right? And that's where our training platform comes in. So each and every one of the students should try these things out on their own. And again, going back to this obsessed with learning, right? We would like to have a learning curve so that we are taking one step at a time, the approximation of the next learning item, instead of a learning cliff where we just fall off because there's too many things that we need to go through, right? So back in the day, it wasn't really Docker or Kubernetes we asked people to install, but we sent out an email saying, hey, we're going to have a training next week. Please install Jenkins on your machine and be ready for things. It's going to be awesome, right? But at some given point in time, the Weasel got invented. The Windows Enterprise Standard Laptop. How many of you know about the Weasel? Can I give a hands up? All right. Oftentimes when I look at the Weasel or when we encounter this, then it goes more like this, right? Computer says no, we have to call IT department. The first couple of times I saw the Weasel, we never got around to actually do any learning on their machines, right? Because it just couldn't install, right? So we needed to come up with some fast way of separating the computer from the student and the ability to learn. And the first one was really hacky, right? It was some shell scripts that talked to the AWS API to create some EC2 instances, create some PEM files and PPK files and an IP address, and then an email to the poor Windows guys saying, hey, you're about to learn Docker. Please go in and download portable PuTTY. Yeah, you don't know what that is, right? And then take the IP address. Maybe you know what an IP address is, maybe you don't. Then the PEM file or PPK file, but not both of them at the same time, right? Can you see that we are not on a learning curve right now, right? We're on a learning cliff. Because they needed to install or need to understand PPK, PuTTY, SSH, PEM, maybe curl, maybe Vim, maybe Nano, before they even could go into understanding what it was that we were talking about, right? What they should learn. So we wanted to go back from the cliff and onwards to the curve again. So the second iteration of our learning platform was a full embrace of infrastructure as code, right? We built everything on Terraform. It was modular, it was layered, it was considered best practices of all different kind of things, security-wise, et cetera, et cetera. We wanted to be the flagship of how to do infrastructure as code. Right? We got URLs, so instead of handing out a random IP address to a person, we could ask them to just go into workstation2.k8s.eficode.academy, for example. Or even better, when we went into that IP address, they didn't get only presented by a terminal, but they actually got a Visual Studio Code in the browser. So now we completely decoupled the way that, or the weasel from the user, right? The only thing that they needed was a working browser. And I have today to have seen many places where that doesn't work. There are some, but that's firewall and corporates and yeah, all that thing, right? So we went from almost not having everybody onboarded when we ended a one-day training to have everybody onboarded within 5 to 10 minutes. So it was magnificent, right? It was a huge leap forward in the way that we did learning and training. And it was magnificent, and it was very secure, and it was totally unmaintainable. The reason for this is that all of a sudden there were multiple different places where we could implement things, right? We could implement it in Terraform with all the different HEL language scripts and all of that. We could implement it in plain bash if we wanted to, quick and dirty. We could also implement it in Make, which were our build system, or we could implement it in Kubernetes through YAML, right? So different features got implemented different places in the infrastructure. And since there were no real product owner or architect around this, it was pretty random where things got implemented. We also ended up with almost 10,000 lines of code, and I haven't told you the newest iteration, but last time I looked, we were under half of the lines of code there, right? So reducing the scope as well for this. Then one of my former colleagues went in and said, what if everything was just Kubernetes, right? The old one here was based on EC2 instances still, right? But what if everything was Kubernetes? So we talked a bit back and forth and said, okay, from the infrastructure perspective, we wanted to build on top of Kubernetes. We wanted to work with all existing courses. I didn't want my Artifactory course not to work on this because Artifactory is not cloud native capable or anything like that, right? I want everything to be moved because otherwise I would have double maintenance. You can hear I'm being the product owner here, right? And Sander being the eager developer. And we wanted to be as cloud native as possible and as declarative as possible, right? We want to get away with this bash scripting all the way, right? And for the user, which is only one point, but it's actually really important, we wanted to look and feel like a virtual machine. We didn't want people to go into a training where the trainer needed to remember saying, oh yeah, and when you run this command, it gives you an error, but don't you worry. I mean, that's only the implementation's fault, right? We want it to be as transparent as possible for the user to receive learning. So let's go a bit through it. The landscape looks something like this, right? We stick to AWS. I'm not an advocate of AWS or any of the other clouds. It's just the one that we had most knowledge about, right? And the workstation over here, I'm not going to point because then you can't only see one of them. So we have the workstation. That's my, as a trainer, the computer where I'm spinning everything up, right? So basically, it goes through either EKS-CTL or through Helm charts or through bash scripts that then talks to AWS because some things can't be, yeah, we'll get back to that. But basically, everything inside the cluster, everything that we need from DNS routes to ingress controller, load balancer and everything, it's controlled through the cluster because we have all these nice controllers, right? And that enables us to create custom resources that are just being there, right? So every time we ask for storage, we'll just get a elastic block storage from Amazon. Every time we ask for an ingress route, then we will get the route from Route 53, and we'll get the load balancer to make sure that the rules are there. Really, really nice. The whole thing was also migrated from Make to Task. For those of you who don't know it, Task is very much inspired by Make. It is a bit easier to understand, but there is one key feature that I would have loved, and that's a dash dash keep going. So if something breaks, I just still wanted to tear down whatever it can. But otherwise than that, it enables us to do a layered approach where you can see here all the includes up there. There's only 3 in the example. Argo CD, Docker, and workstations are different tasks that we're doing on different pieces of the infrastructure. Again, doing it a bit modular in the way that we are approaching this. And basically, the user should just type task deploy, of course, logging into AWS first, and then everything should be set up. So again, that the trainer might not be very well versed in neither Kubernetes nor AWS, and nor should they, right? The reason why we chose EKS-CTL is because it's very opinionated. And in our way, it's a good thing. The opinionation makes us not care about VPCs or what's called security groups or anything like that. Basically, what you see here is everything that it needs, a bare minimum that it needs for us to get a cluster, to get all the nodes up and running, to get the node IP addresses public in a network, etc., etc. It's really nice, and it's so much simpler than what we need to do in, for example, Terraform or any other non-opinionated general purpose infrastructure as code. And it's still infrastructure as code, right? We can still do up and down there. Everything else is Helm charts, right? In the task file that people are creating when they are spinning things up, we can just say, do we want to install Argo, yes or no? Do we want to install Istio in our cluster? Do we want to install Artifactory? Do we want to install Firefox in Docker, which is another project that if I don't go over time, I can talk about. But basically, this is very easy for the user of the infrastructure to click on and off the capabilities that they need. If I'm having a Artifactory course, I don't want Istio to be there as well because it can interfere. But I can still do feature flagging here. The workstation itself is also completely Kubernetified, right? So it goes on with a deployment. We don't have high availability, so the replica count is always 0. But we cater to it in such a way that we have persistency, so we can kill the deployment or the pod through the deployment. If we want to upgrade the Visual Studio Code that we're having, then we can do that on the fly. Other things that we're doing there is quotas and limits to make sure that when we are 12 students and me in a cluster, shared cluster, and I'm talking about deployments for the first time, then there's a non-zero chance that somebody will try to do 100 replicas of something, right? So having some limits to make sure that people are not overstepping each other's boundaries. Having the last talk, I don't think that we have totally isolated everything, but that's a different story, right? And then a view all for the entire cluster. Everybody should be able to see everything, but only manipulate whatever they have in their own namespace. So it's a safe sandbox for them to try out, but also to look at other places. All right, so let me try to illustrate how this works. So while it takes around an hour to spin up, so again, we can't do that here. I've already as a good, what's called TV chef, done some of these things. So basically, the user of this have an environment file that basically goes in and say, how many workstations do I want? How many load balancers? We'll get back to that. How many nodes do I want? What type do I want? And of course, some tagging so that I can hunt down the people who forget to close down their clusters. And then the flag saying, install Argo, install Istio, install Firefox or Artifactory, et cetera, going in. Basically, that's it. When I do that, task deploy, an hour later, everything is set up. And the user will be greeted with this, a complete Visual Studio Code running in the browser, right? So this is not something special with my Firefox or anything like that. If you behave afterwards, you can go into the URL as well, but please don't do it right now. And I can do things like Docker PS, for example, and it will tell me back, or I can do Docker run on port 80:80 nginx, and then it will clone down download the image, and then I can take my URL here, and then hopefully over there, port 80, oh, not 8084, but just 80. see. No. All new browsers have a tendency to, by default, to go over to HTTPS. Like this. And then not the last one. There we go, right? Welcome to Nginx. So it looks and feels like a virtual machine with an IP address, or at least a URL that we can go into. And I can also, there are some tunneling, so I can go in and forward things. It's also, as we talked about just before, I can do K9S, for example. I've installed multiple different tools in there so people can look around and have a good understanding on what it is. And as I said, everybody can look at anything, but they can't just delete Argo CD, for example. We also have implemented Prometheus and Grafana, so I can see whether or not my scaling group is behaving or not. And then last was the over here, this one. So sometimes when we open up, for example, a node port, it comes with an arbitrary high number port. And some enterprise firewalls doesn't really like us going in, even though it's HTTP requests. So therefore, we have also created a small application where I'm having a Firefox browser in a browser, but on the cluster, so that I can access things, right? A bit of a chicken and an egg, but it works, right? And it solves the problem where you have way too, so I can go on DRDK, for example, here, and then we can scroll. There's some breaking, don't want to do that. Oops, over there. I hope you get the idea here, right? We have multiple entry routes towards this, and we have tried to gate it ourselves towards the weasel and everything that comes with that. So, why are pods not VMs, right? Everything I've showed you behaves like a virtual machine. Let me just tell you, it wasn't easy. First of all, persistency, right? So, one thing is persistent volumes and all of that. There is one gotcha when you're upgrading your memory from Docker to Kubernetes, is that when you're doing a named volume inside Docker, you mount something that is already there in the image, in the container, then Docker copies over whatever is in the image over to that particular pod. Very neat feature. I don't need to do anything there. But persistent volume claims doesn't do that. So if I go in and mount home, then all of a sudden, everything is gone. So we needed to do some trickery saying, is home there? If not, then put a flag, copy things from another place, etc., etc. It's trickeries. It works. Is it nice? I mean, the other thing is that we're able to spin up new nodes if we wanted to. And Kubernetes is fantastic at rescheduling things if supply and demand is not right at one of the particular nodes, right? The problem is just that EBS's, Elastic Block Storage, inside inside AWS, is not redundant on the availability zones that are in AWS. So all of a sudden, we get a pod scheduled on a node that doesn't have access to the persistent volume claim. That's not good. Our solution there is just to go non-high availability, simply because we're having these, infrastructures up and running for 1-2 days tops, right? If AWS goes down, we have other problems to solve than just that. We could have chosen another, but this was just the simplest way, saying, is it actually something that we need? Do we need the planet scale, hyper, high availability? No, not really. It works. The other thing is ingress, right? So again, me as a product owner, I had a virtual machine before. It had all ports open. It was nice and fantastic. I want the same thing inside Kubernetes. And I mean, so I want port 0 to port 50, no, I can't speak it right now. So a lot of different ports, right? So how hard can that be? Well, it can be pretty tough on one pod, right? I mean, in services, we can still do one service. It can't do ranges, but we can just do like a list of more than 60,000 lines. So it will do. It's not pretty, but it will do. In ingress, that's not pretty nice. And when we're doing big deployments at schools and universities, when we're out teaching there, we're having 100 workstations. 100 workstations times more than 60,000 ports gives us 6.5 million ingress routes. Ouch, that's not good. So we were looking at this, and then we're like, okay, so how many load balancers do we then need, right? Again, one load balancer, one IP address. The way ports work is that you cannot allocate one port to more than one application. The way that all of this works means that I need to have 100 load balancers for 100 pods. I don't know about you guys if you can remember the pricing of a load balancer, but it's a non-zero timing, right? So it will cost us around, I think it was $100 per day just to run the load balancers. Wouldn't work. The other thing is that load balancers inside AWS only are able to attach up to 200 rules, which means that we can not even have one for every 65,000 port rules. No, we needed to divide it by 200, right? So we would have a lot. No, not found. We needed to go back and say, do we really need all the ports? And as a product owner, I got sad. But afterwards, it was this cliff, and then I was like, okay, we need some ports, right? We need port 8080, we need port 8084, we need port 80, some of these, right? I can choose 6, and then we can have that. Because then again, still when we're having 100 pods, then it's not a big issue, right? 100 pods, 100 services, 600 ingresses. I mean, it's not nice, but it's doable, right? More than 6 million. And again, with the way that AWS works, we then divide it by 6 different load balancers. So all in all, sort of works, all good. The next thing is Docker in Docker. So the easiest way for us to do this is just to mount in the Docker socket for the node onto the pod, and then things are working, right? I can do Docker run commands. But the problem is that now I'm sharing the context between 2 workstations. So if I'm asking people to say, hey, Docker run with this Alpine and give it a name KCD, then the first guy coming in will receive a yes, and then the next one will not be able to do it because the name is already reserved, right? So again, going back to, we don't want a place where we can't see this as an isolated learning experience. The way that we solve this is with Sysbox and Cryo. And it's way either above or below my pay grade to understand exactly what Sysbox is doing. But consider namespaces, kernel security things, security groups and all of that, enables it to make sure that we inside the pod can actually have our own Docker engine. So as long as everything is running through Sysbox and Cryo, then we're actually able to install and enable Docker engine inside of them. The only thing that we need to do within the deployment in order for Sysbox to be enabled is to go in and say, okay, well, the runtime class now is not run C, it is Sysbox instead. So that one takes care of all the security. We don't need to configure anything else in that. That's really, really nice. So it looks and feels like a VM-ish, right? I mean, the only thing is the port, but if I don't ask people to open up port 5000, then they won't know that it's not working. It's less unstable, and I think it's really about that things are going down in the same pace as it was before, but Kubernetes with all this reconciliation loop just makes things go up again, right? Very nice feature. Who would have known? It's easier to use. Basically, it's so much more easy to spin up things than it was before, and right now it's easier to maintain. My guess is that it's easier to maintain because it's new, right? I would think that in 5 years' time, I could go up and have exactly the same talk with a new version of this, built on something completely different. The other nice things about this auto-reconciliation is that we can actually scale the entire clusters down to 0. At least 0 worker nodes, right? Leaving everything in a pending state. So again, we know that when we're doing training, nobody should at least go in from, let's say, 9 o'clock in the evening to 7 o'clock in the morning. There we save 25% of our AWS bill by just turning off the EC2 instances. And then, yes, nothing is deployed, but it doesn't matter, because we can just spin it up again at 7 o'clock. 2 nodes come up, everything slowly getting deployed. All the persistent volume claims are still there, so everything works just perfectly afterwards. And we can also bet a bit more than we could before. So, what's it called? If we take the biggest node from Amazon, it's the T3 2x large in the T3 area, right? Then normally we have around 16 T2s or T3 smalls on there, which means that we are paying 16, like we're paying for 16 virtual machines on that part. But if we're to leverage all that CPU and all that memory, we can actually give people a bit more leg room. Not that everybody can use it at the same time being noted, right? Because we can't have people going in and using 3 gigs of memory and 6 CPUs, because the entire machine only have 8 CPU cores. But when we're doing this, we found out that people are spiking in very different ways and in very different time zones, meaning that we can actually pack things more together while still giving people access to more CPU. Because on a T3 small or T3 small, you only get 2 CPUs. On the other one, we can give you up to 6, because if there's more idle time, we can distribute that. Very, very nice. So, are we there yet? I didn't want to use the real donkey here because of copyrights, but so who runs the world, right? All of you have one word in your head, and that's probably bash, right? To me, bash is the glue that puts great applications together, right? And we still, like, one of our primary things was that we will get away with all this scripting, right? It should all be declarative. If we looked at the old and the new implementation, we actually increased the percentage of bash. We got around fixing like a few hundred lines of bash down, but we actually got more bash than compared to all the other things, right? And I don't know whether or not we can totally get away with it. Because while declarative and reconciliation is better than programmatic in many of the use cases that we actually have one where it's not that good. Imagine this. Every time I'm done with the training, I want to kill the entire cluster and everything that it has to do with it. I could just go in to EKS-CTL and make it just delete the cluster. But then all the corresponding resources out in AWS would be dangling. And I have no easy way to figure out if I have deleted an ingress route inside Kubernetes, whether or not I am fully 100% sure that the corresponding route 53 is actually deleted. Which means that right now we're going to do this double vacuuming thing, where we're first trying to vacuum things from inside the cluster, then we're deleting the controllers, then we're deleting the cluster, and then afterwards we go in with some AWS CLI. Right? Not really nice, but let's see if we can't get a nice solution with that at some point. That was my talk. I hope you took some of these things away. Why pods are not virtual machine. Thank you.
Thank you so much, Sofus. We still have like 6 minutes left, so if there's any questions, please raise your hand and I'll come running with a microphone. Do you see anything? There's so much light.
No.
No questions. Oh, that will. I guess that this is that will leave you with 5 additional minutes for cake and coffee. So I think that it should be outside. So see you in, what is it? Is it 10 minutes past? Yeah. You can check the schedule.